Now I'm going to talk about exponential functions with reference point and domain and range. Exponential functions have a specific formula that is y equals n to the x power. This formula is used originally to make a graph of something that is growing or decaying extremely fast. Normally, in most of the cases, in representation of the formula, y equals the quantity and the number of things, and x equals for the time, depending on the problem. Sorry, I'm sick. Now, we're going to talk about how to graph. We're going to use this exponential function that is y equals 3 to the x powered. As for every atom that splits, more neutrons are released, along in relation with the exponential growth and mass destruction. First of all, you have to write the graph. Then you have to define the table of values that is from -2 to 2 and complete the y section with any mathematical resource. We recommend calculator. Then with the table of values complete, you have to write the points in the graph, and like this you can finish writing the line in between each point, so you can have the graph complete. And with this you can find all of these things. The reference point will be 0,1. The reference point normally varies depending on the function, if it's negative or positive, like growing or decaying. The domain will be from -infinite to infinite. The range will be from 0 to infinite, and the asymptote will be y equals 0 because it doesn't touch the 0.
The 1986 accident at the Chernobyl nuclear power plant in Ukraine is the only accident in the history of commercial nuclear power to cause fatalities from radiation. It was the product of a severely flawed Soviet-era reactor design combined with human error. 28 highly exposed reactor staff and emergency workers died from radiation and thermal burns within 4 months of the accident. Officials believe the accident also was responsible for nearly 7,000 cases of thyroid cancer among individuals who were under 18 years of age at the time of the accident.
This is a paired formula, also known as a continuously compounded formula. A is the ending amount of whatever you're dealing with, money, bacteria, or radioactive decay. P is the beginning amount of A. R is the growth or decay rate, and T is the time taken. So how can we apply this exponential growth formula into a real-life example? A clear example of this formula can be applied into a bank investment which is continuously compounded throughout time. This means that your investment will be in constant growing state, increasing your profits. Let's take this case for example. If you invest $20,000 at an annual interest rate of 1% compounding continuously, we can calculate the final amount we will have in the account after 20 years. This example we want to find A, which is the final amount of money we will have after 20 years. P is our initial amount. We multiply this times E. Then you have to apply the exponent multiplying 0.01, which is the rate, times 20 years, which is the time taken, and then you will have the ending result of $24,428.05.
Predict the population growth. Our goal is to predict the population of Mexico in the 2020 with the help of the exponential function formula. This formula is A equal P, open parenthesis, 1 plus R divided by N, close the parenthesis, multiplied by the time. The A is the final answer. The P is the population of the 2016. The R is the annual rate of population in Mexico. The N is the compounded annually. The T is the time in years. Now we can put the values on the formula of the exponential function. Our final answer will be 134.268 millions. That will be the population in Mexico in the 2020.
What is exponential growth? What is the function and graph that models and represents it? Is the increase in a rapid rate in proportion to the growing total number or size? The function are the numbers that projects the actual rate, and it's what models and express the graph, and the graph will depend on the number and signs that are used on it to define if it is increasing or decreasing with positive or negative numbers.
We are aware that some implications of this type of energy are nuclear radiation accidents, such as the one with Chernobyl, and radioactive wastes. Nuclear energy helps the pollution in the air because they generate heat from fission rather than burning fuel. They produce no greenhouse gases or emissions associated with acid rain or urban smog. Doing our research, we learned about a nuclear plant named Central Nuclear Laguna Verde located in Alto Lucero de Gutiérrez Barrios, Veracruz, and is the only nuclear energy plant in Mexico that produces electricity. We believe that working with nuclear energy has incredible benefits, but we are concerned that the nuclear plant in Mexico is in poorly conditions. We found out that in the database that in 2006, during Hurricane Roxana, the wind blew out the ceiling, which contained radioactive material. The location isn't favorable neither. It's located near the ocean and in a seismic zone. Considering this, we shouldn't have a nuclear energy plant in Mexico until we have the safety regulations and technology to support this kind of technology. There were many consequences involving the Chernobyl 1986 disaster, such as radioactive fallout particles, ozone depletion, and human radiation, these including blood disorder, cataracts, and malignant tumors. The consequences of natural disasters and nuclear weapons in relation to our environment, bacteria, species, and any animal or living thing is dead by the radiation, and this radiation stays in the same place. We don't feel afraid of this, since all humans can commit errors, and a solution to this could be to learn from errors so people that manage a job can have a more awareness and visions of what could happen if other things do. As a whole, we enjoyed working with students from different campuses. It definitely gave us a wider view of what to do since ideas came out of everywhere. Although at first, thought difficult, we realized communications were easier than expected and shouldn't require meetups, thanks to our phones. Using this technology, we created group chats where we could agilize contact with our teammates and deliveries rather than any mails. And we also created a drive where we could share our work at any time, anywhere.